When cherry blossoms scatter across the Kyoto Plant's test track each spring, they land on some of Japan's most sophisticated engine blocks. Mitsubishi's master craftsmen, many third-generation engine builders, work in near-silent precision beneath Mount Hiei's shadow. Their workspace is a curious blend of Zen garden precision and industrial might, where robots and ancient timing techniques coexist. Deep in the industrial heart of Japan, Mitsubishi's engine production facility stands as a monument to precision engineering. Within these walls, raw aluminum blocks and steel components are transformed into the beating hearts of vehicles through a process that combines centuries of Japanese craftsmanship with cutting-edge robotics and automation. The journey begins in the facility's receiving department, where specially formulated alloys arrive in precisely measured billets. These materials are subjected to initial quality control scans, checking for microscopic impurities that could compromise structural integrity. Even at this early stage, laser spectroscopy analyzes the molecular composition of each batch to ensure it meets Mitsubishi's exacting standards. The facility's environment itself is a marvel of industrial design. The air filtration system, borrowed from semiconductor manufacturing, maintains a positive pressure environment with fewer than 100 particles per cubic foot, a level of cleanliness that rivals medical facilities. Workers, dressed in white cleanroom suits, move meticulously between production zones to maintain this pristine environment. In the initial machining area, 5-axis CNC machines begin the transformation process. These computer-guided systems, capable of maintaining tolerances to within 0.01 millimeters, carefully sculpt engine blocks from solid metal blocks. Each cutting tool is monitored in real time for wear, with automated systems replacing tools before they can produce even slightly out-of-spec components. The machining process itself is choreographed to minimize waste. Up to 98% of metal shavings are captured, recycled, and repurposed. The facility's automated material handling system represents the pinnacle of Industry 4.0 integration. Laser-guided vehicles navigate using a combination of floor-embedded magnetic strips and ceiling-mounted QR codes, maintaining positioning accuracy to within millimeters. These autonomous carriers communicate via a dedicated 5G network, coordinating their movements to optimize traffic flow and energy efficiency. Each carrier is equipped with load cells that constantly monitor weight distribution, ensuring delicate components are transported without unnecessary stress or vibration. Quality control stations punctuate every stage of production. Advanced metrology systems employ blue light scanning technology to create detailed 3D models of each component, comparing them against CAD specifications with micron-level precision. Thermal imaging cameras monitor temperature variations during machining, while ultrasonic testing reveals any internal imperfections that might compromise structural integrity. Machine learning algorithms analyze this data in real time, identifying potential issues before they become problems. The assembly line exemplifies the perfect marriage of human skill and robotic precision. Collaborative robots, or cobots, work alongside skilled technicians, each performing tasks suited to their strengths. Robots handle repetitive tasks requiring consistent force application, while human workers manage complex assembly operations that require judgment and finesse. Each worker's station is equipped with torque monitoring smart tools that provide real-time feedback, ensuring every fastener is tightened to exact specifications. The engine testing facility resembles a scientific laboratory more than a traditional dynamometer room. Each test cell is isolated on its own seismic pad to prevent vibration interference. Multiple sensors monitor over 200 different parameters during testing, from conventional measurements like power and torque to sophisticated analyses of combustion chamber pressure waves and thermal expansion patterns. High-speed cameras capturing 100,000 frames per second monitor valve movement and timing chain behavior. Engines undergo a sophisticated break-in procedure that simulates various real-world conditions. Computer-controlled dynamometers vary load and RPM according to carefully developed algorithms, while thermal imaging systems monitor heat distribution across the entire engine. Sophisticated acoustic analysis software listens for any abnormal sounds that might indicate imperfect assembly or component interaction. After all the rigorous testing methods are exhausted and the engine proves it mettle, it is packed and transported to one of the many car assembly factories run by Mitsubishi. One such facility is in Mizushima. The Mizushima Vehicle Assembly Facility represents another leap forward in manufacturing technology. The assembly line employs a revolutionary multi-axis vehicle positioning system that can raise, lower, or tilt them. This flexibility allows workers to maintain perfect ergonomic positions while performing assembly tasks, improving precision and efficiency. Robot-assisted assembly operations utilize advanced force feedback systems that can feel when components are properly seated. The windshield installation process, for example, uses precision robots that apply exactly the right amount of urethane sealant while monitoring temperature, humidity, and cure time to ensure perfect adhesion. Similar systems handle delicate tasks like wire harness routing. Final vehicle testing employs a combination of physical and virtual validation. Cars undergo testing on a sophisticated four-wheel dynamometer that can simulate various road conditions while monitoring vehicle behavior. A battery of sensors collects data on everything from suspension movement to cabin noise levels. This data is compared against virtual models to ensure every aspect of vehicle performance meets design specifications. Before leaving the facility, each vehicle passes through a light tunnel equipped with high-resolution cameras that create a complete 3D scan of the exterior, checking panel gaps and paint quality. Advanced imaging systems inspect every electronic system, while thermal cameras verify the proper operation of all mechanical components. A highly skilled engineer follows this up with a final visual check, and the car is finally ready to be delivered to a proud and happy customer. This level of sophistication is a testament to Mitsubishi's unwavering commitment to engineering excellence. Every engine and vehicle that emerges from these doors carries within it the accumulated knowledge of generations of craftsmen, enhanced by the latest advances in manufacturing technology. It's where tradition meets innovation and where the future of automotive engineering takes shape.